Newton's first law of motion states that when an object is either at rest or in motion, that object will remain at rest or in motion unless it's acted on by another force. What this law is saying is that if you have an object that's not moving, like this green ball here, it's going to remain not moving forever. It also says that if we have an object that is moving, like this purple ball here, it's going to keep moving on forever unless something acts on it to change that. If we were to plot the velocity versus time graphs for both of these balls, they would both be horizontal, with the green ball being right at 0 and the purple ball being above it at whatever its velocity is. With both these lines being horizontal, that means that the change in velocity with respect to time is 0. The velocity is not changing anywhere, which also makes the acceleration equal to 0. Now, this doesn't mean that there's no forces acting on the object. Now, if we look at the equation that governs this law, that the sum of the forces equals mass times acceleration. Go ahead and plug in 0 for our acceleration because we know what that is. So we have the mass times 0, which is just 0. So the sum of the forces acting on the object when it's either standing still or moving at a constant velocity equal 0. Put this a little closer. Let's take the following situation where we have a ball sitting on a table. Now, if we go ahead and remove the table, we can look at the forces acting on this ball. We know that there's gravity pulling downward on this ball, and the table is pushing upward on this ball, opposing it. We're using its normal force. Now we know the sum of the forces equals 0 because the object's not moving, so therefore it doesn't have an acceleration. With this information, we can go ahead and write an equation to determine our forces now. So we know the normal force, which we'll represent with an N. It's upward, so we're going to make it a positive force. Now the force of gravity, we'll represent that with F sub g. It's a negative force, so we'll go ahead and make that negative. We know it equals 0. So now we can go ahead and solve for the normal force by adding the force of gravity to both sides of the equation. And so that makes our normal force equals the force of gravity. Even though two forces are acting on this ball, since they're canceling each other out because they're equal and opposite, that leaves us with a net force of 0 and a net acceleration of 0. So that's why the object's not accelerating.